Okay, welcome to the Pythagorean Theorem, starring our friend right triangle. But first, a word from our sponsors on how to watch a video properly. In order to watch the video properly, you have to listen and take notes. It's not just enough to take active notes, right? Work along with me, but you must listen to the video. From time to time, I'm going to ask you to pause the video and do some work on your own, right? So when asked, pause and solve problems on your own. Otherwise, you're not going to walk away with much knowledge or practice from these videos. Lastly, don't be afraid to ask questions. Just because you have the video doesn't mean that you can't come up to me and ask me questions in class. Follow up with anything that still doesn't make sense. Okay, onward and upward. First, we're just going to take a quick review. Keep in mind that when we have our triangles labeled ABC, C is generally the hypotenuse, and the hypotenuse is always across the street from the right angle. A and B are both referred to as legs. The Pythagorean theorem itself is used to find the missing sides of a right triangle. Sides A and B are called the legs, C is called the hypotenuse, and a squared plus b squared equals c squared is the Pythagorean theorem itself. Now that we have that speedy review, just remember we can always just call this the hype, H-Y-P. Let's move on to some problem solving. You should recognize this. This is number 2 from the handout. And I find the right angle, and across the street is the hypotenuse, right? That's the hypotenuse. So I'm going to write a squared plus b squared equals c squared. And now on my next line, I'm going to substitute. So this is part 1 of a 3-part process. Number 1, write the formula. So here's my number 1, step 1. Step 2, substitute in known values. So the first thing I like to substitute in is the hypotenuse in its correct spot. So here's our hypotenuse. So we're going to say that goes in for C, that's x squared. So it looks like we're finding the hypotenuse, which is the long side, right? This is the longest side of the triangle. And then the other 2 are the legs, so I can put 27 and 22, and it doesn't matter where they go, left and right. Addition is commutative, and so 27 squared plus 22 squared is the same as 22 squared plus 27 squared. And now the last thing we're going to do down here is solve for the unknown using our algebra skills from last year. When I square 27 and 22 and I add them together, I get a value of 1213 equals x squared. Now I'm going to use algebra to undo both the squared side, and whatever I do to one side I do to the other. And the square root of 1213 is approximately 34.828 is equal to x. So to the nearest tenth, according to the instructions, it says round to the nearest tenth. Since this is a 2, I'm going to leave that at 8. And I should, little squiggly line here. X is approximately 34.8. So this length right here is approximately 34.8. And that's longer than 27 and 22, so that makes sense. Press pause if you need to and catch up. Check your answers, ask any questions. Let's move on. So again, I'm going to go dive into my picture, and I'm going to find the right angle. Across the street is my hypotenuse, right? And these are the legs, so that's a leg, and this is the hypotenuse. And I'm going to have a squared plus b squared equals c squared. Following that step-by-step process, I'm going to substitute in the hypotenuse first, 30.5, and keep in mind that that is the longest side of the triangle. 19.1 and x go on the other side in either order with addition between the 2 of them. Now let's go ahead and square those values. I get 364.81 or 364 and 81 100ths plus x squared equals 930 and 25 100ths. Now I need to get x squared by itself, so I'm going to subtract 364.81 from both sides. And I get 565.44. Now I need to undo the square, so whatever I do to one side, I do to the other. The square root of x squared is x. and the square root of 565.44 is approximately 23.778. So rounded to the nearest tenth. If I want to round to the nearest tenth, I look here. That's bigger than a 5, so this is going to be 23.8. That's a kind of rough looking 23.8. I'm going to rewrite that. And that is the length of this side right here. Now, this side should be smaller than 30.5, and 23.8 is, so that is a reasonable, sensible answer. Move on. Press pause if you need to catch up, ask any questions if you need to, and then move on. Now we move into a little uncharted territory. I no longer see a right triangle, I see an isosceles triangle. An isosceles triangle has at least 2 congruent sides. So I'm going to just put the definition right up there. And so where are my congruent sides? Right here and right here. Or I should say this side and this side are the same length. Now, since that's an isosceles triangle, we have this dotted line going down the middle. What we have essentially is this. This is just the left side of that triangle. This is a right angle. This is 24. And since the whole length is 22, this is half of that, 11. Now I have the hypotenuse is right there. This is the unknown side. So I have a squared plus b squared equals c squared. Who do I substitute in first? The hypotenuse, which is 24 squared. And the other sides are going to be 11 squared plus x squared, right? Now we're going to solve for x. So eventually you're going to be able to get an answer for x. And what's that? Happens to correspond to exactly what we're looking for. So you can finish this one on your own. Now, what do we have on this side? Over here, we have ourselves a trapezoid. This is a 4-sided polygon, right? Just throwing some words at you, a little bit of vocabulary, but most importantly, you need to know that this is a trapezoid. And so what I'm looking at here is sort of trying to just take this idea and trying to see the figure inside the figure. So I think that I have myself a nice little rectangle. Now, if this is 5, this is 5, and if this is x, this is x. Now, if we just kind of think about that, that means that this is x and this is 5. If the whole thing is 18, then let's get another color in here. How long is this green side? I think that that green side would be 18 minus 5, which would be 13 units. So we have this 13 unit piece. So now let's just draw what we have. We have the rectangle over here. That's this piece. And now we have this triangle. This is x, this is 13, this is 16, this is the right angle, and that's the hypotenuse. So what do we got? A squared plus b squared equals c squared. And 16 squared is the hypotenuse piece, the c piece, and I got x squared plus 13 squared. Now you can solve for x, and that's going to be this side right here, but whatever this x is too, because I made that a hypothetical rectangle, and both sides would be the same value. So you finish this one on your own. Let's move on. You can press pause now and finish these two, or you can continue to set up the other problems, whatever works for you. This is your pace, your time. Again, kind of a similar problem. We're going to break this into a couple of pieces. I'm going to call this the red triangle, and then I'm going to call the other one the green triangle. So I'm going to draw those separately. Here's the green triangle right here, right angle. I'm going to call this Z. I'm going to call this 12, and this is 29, so that makes 29 the hypotenuse. So amazingly, I can already set this up. A squared plus b squared equals c squared. Who's the hypotenuse? 29 is. Who are the legs? 12 squared plus z squared. And you can solve for z eventually, right? So you solve for z. Next, we come to the red triangle. The red triangle is set up like this. And I know that I drew it a little bit larger than this one, but this 12 is also right here. It's the same shared side. So that's 12. I'm going to call this y and this 14, and that's the hypotenuse. So a squared plus b squared equals c squared. The hypotenuse is the 14, so that's 14 squared. And over here we got 12 squared plus y squared. You can solve for y. Now the question is, how long is x? Well, x is going to be this piece plus that piece. This was y and this was z. And you should have the answers for those down here. And now your final answer will be right here. This is your FA, final answer. Press pause, work it out, then move on. Now notice I skipped number 10. We're just going to move on to 11. Kurt is building most importantly, a rectangular deck. So what should you draw a picture of? Always draw a picture. Okay? Word problems absolutely require a diagram. Let's make that a triple explanation point. Okay? You must draw a picture to see it. Right? The diagram helps you see things. And will give us a little hair and maybe a couple of ears. But you get the point. Okay, so Kurt's building a rectangular deck. If the dimensions, right? The dimensions of the deck are the sizes of the sides. Are 10 feet by 23 feet. So we'll make the shorter side 10 feet and the longer side 23. So that's aesthetically pleasing. But this is a rectangle. So the opposite sides are congruent and these two sides are also congruent. And these tick marks that I'm putting here indicate that we have congruent sides. And remember, congruent, the symbol, means of like measure. So that means that this side is also 10 feet and this side is also 23 feet. But you already knew that because this is a rectangle and that's pretty common knowledge. Now the question is, what is the, right? What, that's the beginning of a question, sounds like to me, is the length of the diagonal of the deck. And where's that? Right there. Now there's two of them. There's one there and hypothetically there's one right here. They're the same exact thing. So we're going to focus on the blue one here. What's the length of that diagonal? Well, how about we just trace out the whole blue triangle? It's right here. We got 10, we got 23, and we got I don't know. Here's the right angle. That's the hypotenuse. A squared plus b squared equals c squared. And here's your c, a, and b. Right? This is a, this is b, this is c. Or, of course, this could be b and this could be a. It doesn't matter. You figure it out. Get a final answer for that length x, which happens to be the diagonal of the deck. All right? Press pause, work it out, move on. Okay, so now we got Ashley. So here's Ashley. She's very happy, and she's got the white hair, and she's also a stick figure. And what's Ashley doing? She's jogging east, south, west. So let's see here. Let's get a compass. Here's our north, here's our east, here's our west, and here's our south. Okay, so Ashley starts out sort of like, we'll say she starts right here. And she's going to go 3.4 miles east. So east is this way. And she went 3.4 miles. Then, from that point, she's going to go 5.7 miles south, due south. Sounds like a right angle to me. 5.7 miles. And the question is, how far is Ashley from her starting point? Well, this was where she started from, and now she's right here. So I think we have to connect the dots. And it looks like we have a right triangle. There's the hypotenuse. You get the idea. Keep in mind this squiggly sign that I keep making means approximately, right? Approximately, not exactly. How far away is she to the nearest tenth from her starting spot? Press pause, work it out, blah, blah, blah. Ask questions, you know the deal. You're doing good. Hang in there. All right, the last question in this video. We have a 31 foot, right? 31-foot support wire, right, is attached to the top of a 25-foot telephone pole. Okay, so I guess we should draw a telephone pole. And how tall is the telephone pole? Right here, it's 25 feet. So this is 25 feet. On a side note, 25 feet can also be notated like that. So, or 25 feet. And what do we have? We have a support wires attached from the top of the pole to a point on the ground. So where's the ground? I'll make the ground in green because that's where the grass is growing, right? So what do? We got this guide wire that goes down here to the ground. This is the wire, support wire, guide wire. And it says it's a 31-foot support wire. So this is 31 feet or 31 feet. Now you know I prefer this notation right here because it's easier to put a little tick mark than it is to write 4 letters, right? Efficient. And the question is, how far from the pole's base? When you hear base, think bottom. Here's the bottom of the pole. How far from the pole's base does the wire meet the ground? Right here. So here's my right angle, and I'm going to draw across to the hypotenuse. I got 25 feet, I got 31 feet, and I got I don't know feet. We want an approximate to the nearest tenth right here. Is that number bigger or smaller than the hypotenuse? That's what you got to think to yourself if you want the answer to make sense. And the better you get at math, the more you can make sense. All right? I'm proud of you. Keep up the good work. Keep asking questions. And keep on keeping on. Thanks for listening.